Now I am explaining how we can solve the LeetCode 79 word search using the backtracking algorithm. So the question is really simple. You have a board and n- uh, cells are sequentially connected horizontally or vertically. So you are given a word like A, B, C, C, E, D. So you can find A, B, C, C, E, D instead of this board. So you return true. S, E, E is also true, but A, B, C, B, we don't have a sequentially connected uh, uh, characters instead of this board representing the A, B, C, B, so we return false. Okay, let's jump to the solution. First of all, in this kind of grade problems, commonly we have a directions, right? The directions for 2 is equal to -1 0 0 1 1 0 0 -1. It is just common approaches, um, and because here we are just looking for the word instead of this board, so we are just iterating through everything inside of this board. And if we have if we have like from a particular cell the condition is true, then we return true. uh, Else, after we traverse everything, we still didn't find a true condition of the backtrack, we return false. Okay, inside of this backtracking algorithm, uh, first is the yeah it is the check conditions like all other cases. Uh, First of all, trivially when the suffix it is the it is the parameter that we put into the backtracking method, or when the suffix length it is equal to 0, trivially we return true. And if the first character of the suffix it is not equal to the character inside of the particular board cell, then trivially it will be false. And uh, uh, if these two cases pass and the suffix length equal to 1, which means the first character of the suffix is indeed equivalent to the cell of the corresponding row and column, then we return true, because the string is just equal to the cell itself. And then we make a copy of the character of this particular cell, and then we put a dot here, which means we have visited this state. And then we just we also we subtract the first character from the suffix, and we make a new suffix. And we're just iterating through all the directions we define here. We have new x and we have new y defined by the directions plus the row and columns. That's basically like a vector. And then we have this the condition: if we reach outside of the board, then we continue. And then if the board has been visited by the lower portion of the stack, we also continue. Uh, then if okay, if the new cell we are visiting has the value not equivalent to the first character of the suffix, which means which means the backtrack will be pointless. We'll also get continue, okay, and then if we eventually reach the true state, we return true, and then the previous stack also pop true and true and true and true. Eventually, we will reach here and return true. Okay, yeah, this is the idea. And if we have a stack return false and previous state, we will have uh, false here, and we will go to the next direction. If in all the directions and all the stacks and we have false, and this stack will also return false. And before returning the false, we set the board, the cell of the board back to the original value. So yeah, and this is basically the idea and the fundamental of the backtracking algorithm. Yeah, and let's run this, and indeed it passed.